Okay, so nets and surface area. So now after we did that demonstration, who can describe what a net is?
An unfolded box.
Okay, so it's an unfolded box. So is there more general terms we could use?
Unfolded three-dimensional figure, actually.
Okay, so it came from a three-dimensional figure, and then what is it when it's unfolded? How many dimensions? 2 dimensions. So it's a two-dimensional representation of a 3D figure. What are what? Well, one dimension, you're only going in one direction, so like a line. Two-dimensional would be a plane because you can go in 2 dimensions. And then 3 dimensions would be solid, so 3 dimensions. Yeah, once you get to the other dimensions, those are referring to things like light and sound and. So, surface area. Who can describe to us what the surface area is of an object? Okay, so the surface area is the total area on the outside of a figure. So the total area on outside of a solid or of some sort of three-dimensional figure. Okay? So if we wanted to find the surface area of one of our 3D objects, how could we do that? Find the area of what? Yep, find the area of each side surrounding it and then add them all up. So that's what we're going to be doing today. So the first thing we're going to do is we're going to draw the net. Once we have the nets drawn, then we're going to find the surface area. So first off, you need to identify what type of shapes we have here. So what type of shape is this? Okay, so this is our triangular prism. So the shape of our base is a what? Triangle. What are going to be the shapes of the faces? Rectangles. See, we have rectangles. Only the bases are triangles. Okay? So, how many rectangles will we have?
3.
We'll have 3 because there's one on each side. Can everyone visualize that? Okay, so what we're going to start off by doing is we're going to start off by drawing our 3 rectangles. So I'm going to draw a large one, and I'm just going to split it up into 3 sections. Okay? Now, where on here would our triangle shapes go? Okay, so our triangle shapes, you think they'd go on the left and the right? Would that fold up right? No, one would have to go on top, and one would have to go on bottom. Pick any side to work off of. I just like usually using the middle side. And I see my triangle has a right angle. So I'm going to make sure I draw a right angle on here. And then I'm going to visualize this right triangle being folded up. I'm going to draw its mirror image on the other side. So there's my net. Okay? Now we want to go through and we want to label some of the measurements we know. So where would this 3 go?
On the
Triangle.
Where on the triangle?
Next to the 90.
Yep, right there next to the 90 going up, so that's the height. So this one down here is also the 3. Where's the 4?
On the bottom.
On the bottom of the triangle, yep.
And on the triangle, or on the rectangle.
We'll get there. And then where else does the 4 go? Because there's another 4 over here.
On the rectangles.
Yep, on the rectangles. Okay, so now let's envision folding this up. So this rectangle here gets folded up and it has to meet with this side. So these 2 sides have to meet, which means if this length is 3, what does this length have to be?
3.
It has to be 3 because they have to meet up perfectly. Okay, do the same thing here. Envision folding these 2 corners together. So if that length is 3, what does this one have to be? 3. Oh, and now we're missing a length. How do we know that's 5? It's a 3, 4, 5 triangle. So now if this is 5, when we fold it up,
5.
that other rectangle will have to be 5, and same thing on the other side. So now we have all the sides labeled. Now we just want to go through and find the area of each individual figure. So a triangle, how do we find the area of a triangle? Okay, so 1/2 base times height. What's your base and height of the triangle?
4 and 3.
4 and 3. So what's 1/2? 3 times 4?
6.
6. So I'm going to put 6 units squared in the triangle and 6 units squared in that triangle.
Oh, you put U squared. That's what I put.
Yeah.
I think what?
U stand for units.
Where's U?
Okay, far left's rectangle. How would I find the area of that?
Base times height.
Base times height. So in this case it is
12.
3 times 4, so 12. So there's 12 units squared there. Middle one, what is it?
16.
How do you get 16?
4 by 4.
Yep, it's a 4 times 4. It's a 4 by 4, so 4 times 4 is 16.
5 by 4.
And the last one's a 5 by 4, so 5 times 4 is 20. And now we just have to add all these up. So we have 12 plus 16 plus 20 plus 6 plus 6. Yep, or you could simplify it to 12 plus 12 plus 16 plus 20. 60 are we getting? So 60 units squared.
That's the hardest to get. Like, that's
Well, we'll have other shapes. Okay, this one okay? All right, let's look at the next one.
U.
What type of shape is this? A cube, otherwise known as what? More specific than a rectangular prism? A square prism would be another word for it.
I thought it was a trick question.
No,
Holy.
I apparently need to turn my volume off. All right, so now we want to draw the net out. So how are we going to do that?
Draw low.
So how many square? Let's think about this as the bases here. So how many squares wrap around those two bases? 4. Okay, so we're going to draw this out, and we need 4 squares in there. I'm not very picky if you're super accurate. Obviously, if you see my drawing. Now, where would the bases go?
On
Okay, one top, one bottom. Doesn't matter which square you decide to put them on? Nope, just put them on the same one. So I'll pick this one. I'll draw a square and draw a square. So now that would fold up to be our cube. What would be the lengths of this one? 5, and where would the 5 go? Yeah, the 5 would go everywhere because these were all squares. You really don't need to write it everywhere, but I will. They're all 5s. What's the area of each individual square?
5.
So each individual square is 25 meters squared. They're all going to be that? So you can write it on each and add them all up. What's your other option?
25 times 5.
25 times 6. Why 6?
Because there's 6 squares.
There's 6 squares. So it's 25 times 6. So here's 150 meters squared would be our surface area. SA stands for surface area.
Do we have to put that?
Our next section will be on surface area and volume, so it'd probably be good if you can distinguish the two of them. Okay. All right. Let's do another one. What type of shape is this?
Triangle pyramid.
No.
A rectangular.
Square pyramid. Why is this a square pyramid?
Both of them they're all 8.
Yeah, here's our base. Base is the same side, so 8. Okay, so now our base this time is a square. So we're going to start by drawing the square out. Now what's the shape of each face?
Triangle.
Yeah, notice each face is a triangle. Where should I put all the triangles?
On each side.
Yep, one on each side. So we'll just draw a triangle going off on each side. Okay, now we want to label what we know. So we know the square's got 8. And then the triangle, what were we given?
10 for the height.
10 for the height. Will that be the same for each one?
Yes.
Okay, so now let's go through and find some areas in here.
The square is 8 by 8.
Okay, so the square is an 8 by 8, so what's the area? 64 units squared. In each triangle now, how do we find the area of each triangle?
10 by 8. Oh, 1/2 10 by 8.
1/2 base times height, so 1/2 10 times 8, which gives you
40.
40. So each triangle is 40 units squared. So how would I find the total surface area?
40 times 4 plus 64.
Okay, so we could do 40 times 4 for the triangles and then add on 64. That would certainly work.
160.
So 160 plus 64. Yep, 224. And units squared because we don't have an actual label. Is that okay?
We have to spell out units. Can we just put
You could do u squared, that's fine with me. All right, and last but not least. Ooh. What is this?
Wait,
Trapezoidal what? Prism, good. Trapezoidal prism. Soy. Soy.
made it up?
Nope. So what's the shape of our faces? Okay, and our bases are trapezoids. So here our two bases are trapezoids, but our faces are all rectangles. How many rectangles do we have around it?
4.
Okay, so there's 4. Now, where would the trapezoid go? On the sides. So one top, one bottom. You have to make sure you line it up correctly. So let's see here. So I'll draw my trapezoid in here, and then do the same exact thing on the other side. So there's my net. Now we want to label. So, look at your trapezoid. This bottom length here says 40. Where is that going to go?
On the bottom of the track.
Yeah, where the trapezoid and the rectangle meet. So those would each be 40. Okay, what else do we know?
Top of the trapezoid is 20.
The top is 20. So now which of these rectangles would that correspond with? Think about folding. Which one would end up being on the top?
The one on the far left.
Yeah, the one on the far left would end up being on the top. So those would be 20. Okay, what else do we know about the trapezoid?
The one on the far right is not.
So here we have, this is
would it be the same thing?
18.
It would still be the same even though I did my trapezoids one thing to the left.
Well, you have to visualize yours differently if you drew it differently on here. So 18 here is this left-hand side, so what rectangle would that correspond with? Yep, the one right next to it. It's the same thing down here. And then what's going to be this length on the right? Right here, look, we've got, yeah, it's 20. It's also listed up there, so 20. Then where else would 20 go?
Right.
Right to the right of it on that one. See, still missing a few things on here. What else are we missing? Okay, the 25 here is the rectangle. So we can finish off each rectangle with a 25. And the one other information we're given about the trapezoid is the what?
The height.
The height of the trapezoid, which we are told is 15. So now we want to go through and find all these areas. So let's start with the trapezoid. Trapezoid, the area is what? 1/2.
B1 plus B. Oh.
1/2 height times b1 plus b2. So let's find that first. So 1/2, the height is 15. Base 1 and base 2 are what?
20.
Okay, so what's this going to be? Half of 15 times 20 plus 40.
450.
That's what I think it is. 450. Okay, so each trapezoid then is 450. Now we have to go through and do each rectangle. So this first rectangle on the left-hand side, what are the dimensions?
25.
Yep, it's a 20 by 25. So what's 20 times 25?
Yeah, 500. Ooh. He wasn't.
500.
He was just kidding.
What's the dimensions of our next one?
25 by 18.
Okay, so it's an 18 by 25. What's that going to be? 450. Next one over, what are the dimensions?
25 by 40.
Okay, so it's a 40 by 25. So what is that? Good, 1,000. And last one is 20 by 25, so 500. So now we just have to add up all these individual areas. So we got 500 plus 450 plus 1,000 plus 500 plus 2 more 450s. What is it? So 3,250, what would we label it as? Oh man. 3,350 units squared.